So, but my u sub version of this, y equals arc cos of u, gives me y prime is negative u prime over square root of 1 minus u squared. All right, so those are the two pieces. And I would like, just like I derived the arctan derivative and the arcsine derivative, you should derive the arccosine derivative. So notice what we see here. We see an angle. Right? So we see an angle, but I don't think in terms of inverse trigs. I think in terms of trigs. So I'm going to say what? Instead of theta is the arc cosine of x over 2, I'm going to say...
invert them.
Good. Cosine of theta is x over 2, right? Nice. So we see an inverse trig, means we see an angle. But we think in terms of trigs. And once I get a trig, I get a right triangle, right? So there's my theta. Adjacent side is x, hypotenuse is 2, and remaining side is square root of 4 minus x squared. Kind of can see a piece of the derivative of our cosine there, right? Something minus x squared. Looks familiar, right? Right? So this is all the information I might have to refer back to, right, when I find the answer. So what is the actual question here? Find y prime in terms of x, right? Find y prime in terms of x. Oh, nice. Perfect. Just opened up. Nice. Did you hear about the, it's not a joke, it sounds like I'm setting up a joke, but did you hear about the truckers? The trucker convoy that's coming to D.C. to clog up the streets to argue about freedom of, to not be able to not have to get a shot, COVID vaccine.
Didn't they do that a few years ago as well?
And they're letting all the high schools out early, all the schools out early today because they think the convoy is going to be today. I'm sure it's some kid in middle school said, the convoy's coming. Better let the kids out of school. All right, so here's my original problem. It's tan of theta. It's the easiest way to think of this, right? It's the easiest way to think of this, right? And theta is what? Arc cos of x over 2. All right, well, that's hinting at me that I need a u value, right? So what is u here? U is a baby sheep. Or is it a baby goat? Which one is it?
X over 2.
X over 2, nice, yeah. And so u prime is what? It's an mx plus b, right? Everybody wake up today, please. It's 1/2. And what is u squared? X squared over 4. So when I see that I'm going to do a derivative of an inverse trig with a complicated interior function, this is my process every time, okay? Okay, I'm ready for theta prime. I'm ready for y prime, right? This is going to help me get theta prime. This is going to help me get y prime. Someone give me y prime. Pedro. What's y prime?
Es 1 over 2.
Pedro.
Hi.
Pedro, where are you?
I forgot to unmute.
Okay, what's that? What's y prime?
Second square. X.
Yes, no, not x. Secant squared
theta.
what? Theta, good. Times what?
I'm lost now.
No, you're not. You're on Earth. You're not lost.
What is the rest of the equation?
It's right here. But I'm doing ddx, right? I'm doing ddx of y, and I'm doing ddx of tan of theta, right? So who's got it for me? What's the rest of this piece? Afsoon's got it.
Theta prime.
Theta prime. It soon's just a little slow. I saw her reaching for the mute.
Oh yeah.
You all know you can just press the space bar anytime and it'll temporarily.
Doesn't
No, it just
Oh,
looks,
yours doesn't do it.
it looks like if the last thing that you did was unmute. If for some reason, like the last thing that you did was turn off your camera, it will turn off your camera.
Well, I'm an FPS player, so I snipe the mute button every time.
All right. So what do I need now? Where am I going to get secant squared theta from? The triangle, right? Where am I going to get theta prime from? Well, this other piece I have working over here on the right, right? So what's theta prime for me? Who's got it? It's very easy.
1/2.
Minus 1/2. Good. Divided by? One minus u squared.
1 minus.
Yep, 1 minus u squared. So 1 minus x squared over 4, right? So I can put it all together now. Everybody with me, by the way? It's weird. It's different. We've never done anything like this in our lives, most likely, right? At this point in our mathematical careers, it's wait till you see what happens in chapter 5. We learn how to drive backward. Right now we're learning how to drive forward, right? We're learning how to do derivatives. And in chapter 5, we undo them, right? And that gets us...
I have a question.
Yes.
For u, or basically not x, the formula, it's a normal formula except the numerator becomes negative u, right?
Yeah, well, so you got to derive...
Is it because it's cosine?
Exactly. When you take a derivative of cosine, you get a negative sign. It's going to throw that negative in there.
Okay.
Yeah.
So that's with every formula. It just becomes negative u prime on top instead of.
For this particular one, let's keep it like that. Let's say
Not for everyone.
I mean, there is a relationship between the sine and cosine, between the arc sine and the arc cosine, between the hyperbolic sine and the hyperbolic cosine. So yes, there's always that positive negative relationship, but let's just keep it to what we know for now. So my triangle again was an x here, a 2 here, and a square root of 4 minus x squared here. So I'm ready to write y prime with a little bit more detail. Secant squared is going to give me
Over x.
right. Secant squared is 2 over x, but I need to square it, right? And theta prime I already have here is minus 1/2 over square roots of 1 minus x squared over 4. So I got a little bit of work to do. Do you see that? I got some things to simplify, and I have fractions within fractions. So I want to fix as much as I can here. How is everybody doing? We okay? Nice. So first thing I'm going to do is I'm going to get a common denominator inside of my radical. So I need a 4 as my denominator, and I can start rewriting here. So I get 4 over x squared times a minus 1/2 over square root of 4 minus x squared over 2. Where'd that the lowest 2 come from? Do you see it? Where'd that lowest 2 come from?
We rooted 4 over 4.
Yes, so I have a square root of 4 in the denominator there, right? So I just took that out as a 2. So it looks like the 2's cancel, and I've got my final answer. I've got a negative 4 over x square roots of 4 minus x squared.
Professor, how did you get that, like, very last part?
So I'm assuming it's right before I crossed out the 1/2. So you're talking about here?
Fine. Like when you multiplied 4x squared in, why do we get x instead? For x squared.
Oh, because Robert screwed up. Thank you. Thank you.
Professor, can you zoom out?
Of course.
So right now with our properties of arc trig functions and the regular, we use that y prime formula, but you're hinting that it's going to change later, or there's something extra.
Not really. Nope.
Oh, okay.
All right.
Okay.
Go ahead. Pedro, you good? Yep.
Yeah.
Nice. Let me just think of off the top of my head a typical problem I put on this next test. I'll say something like find the second derivative. Find f double prime when f of x equals the arctan of x squared, right? So we did that. I'm pretty sure we talked about it a little bit the other day. We talked about arctan of x squared for sure, right? So that's my arctan of x squared. So let's do this one and see how you do. This of course is a arctan of u, right? So the first thing I'm writing down or looking at on my formula sheet is what do I need to get the derivative of arctan of u? So I have it written down. Y prime is u prime over 1 plus u squared, right? So I've got that piece written down. And obviously, right, I know what u is in my particular case. U is x squared. U prime is 2x. And u squared is x to the 4th. Does everybody agree? So this is just a typical problem I would put on this chapter 3 test.
The derivative of arctangent on the top is not u, like the top is 1.
If the argument is x.
Oh.
So, what do we get for our first derivative? Well, it's pretty much instant, isn't it? It's 2x over 1 plus x to the 4th. Right? Do we agree? It's so quick, right? And this is one of those things that when things are really easy, sometimes they're tough because you think, oh my God, I'm supposed to be doing something. Do you ever have that experience in life? Or especially in math, where things are so easy that you think you're supposed to do something and there's nothing to do, right? So in this case, once you are practicing enough, you'll see that this is that easy. It's that easy, okay? But now we need a second derivative. So what's my process going to be?
Quotient.
Yep, quotient rule. So my upstairs function is 2x. The derivative is?
2.
Yep, downstairs function is 1 plus x to the 4th. Derivative is? And when I'm doing my quotient rule, good. When I'm doing my quotient rule, I need that downstairs squared. I'm not going to FOIL things out. I want to factor things, right? Don't want to FOIL things out. I want to factor things as much as possible. I'm doing a quotient rule here. So it looks like my y double prime, at least the upstairs of it, is 2 times quantity 1 plus x to the fourth minus 2x times 4x cubed all over 1 plus x to the fourth quantity squared. This one is easy enough for me just to distribute here. I like to factor if I can, but this one is easy enough just to distribute everything in the numerator and simplify, right? So I certainly can do that here. 2 plus 2x to the fourth minus 8x to the fourth. And it looks like I'm going to have 2 minus 6x to the fourth over 1 plus x to the fourth quantity squared. I can still factor upstairs, and it's probably a good idea to do that. I think we did this problem together now that I'm remembering it. Doesn't matter. It's good practice. It's good practice to do problems a couple of times, right? It's just like playing music. The first time you finally can play a song, it sounds like the song, but it's got no soul, right? It's got no feel to it. And so that's why you're practicing things over. You get it to really have some, you get some deeper understanding of what's going on.
And on that second step for y prime, you simplified, or you distributed and simplified one step, didn't you?
Yep.
Okay.
Yep.
The U. What's the name of the U technique?
I don't know.
That's just inside functions.
I like to say it's a curse. It's like FOU, right? But it is kind of called a use substitution.
And like this like multiplication, like the F prime. What's the name of this technique?
F times F prime. Never heard of it.
Yeah, this one that I drew the arrow.
Yeah, that's me. That's my process.
Huh.
Yeah, can you please unlock Professor, please?
Yes. There's the whole picture. Nice. Got it. Nice, Marcus. Thank you.
Yeah, can you please go back to the previous page, also, please?
Yes.
Thank you.
You're welcome. Nice. So let's do our next section, our last section of chapter 3. And this is derivatives of log functions. So this is 3.7, derivatives of log functions. I never proved to you that if y equals e to the x, then y prime is e to the x. But it's pretty easy to show numerically. It's even easy to show if I do the derivative as a limit and then apply L'Hopital's rule. Okay, so it's very easy to show it. I'd say for Noel, you'd probably want to look at it. Okay, look at the proof of that. I think it does happen in this section, but it's pretty obvious. Okay, now obviously this is the number e, and the book uses base 2 and base 5 and base 10 and etc. etc. I only use base e, both for my exponentials and for my log functions. Okay, so you could go take Calc 2 with someone who uses any base, Okay, so make sure that you just be willing to do the reading of this section to find right if y is 2 to the x, what's y prime, right? Or if y equals log base 2 of x, what's y prime? Okay, so just so you know, you could have a teacher for Calc 2 that would make you be able to do things for any base, but I want to try and rip some of the material out, so I'm going to keep my base e. Okay, so I'm only going to use e to the x and ln of x. So here's our question, right? If y equals ln of x, find y prime implicitly. Don't know if there's an e in there or not. Doesn't matter. Who cares? So obviously we know the shortcut, right? So I already told you that y prime is 1 over x, but I want to do it implicitly, right? So meaning I'm not supposed to have told you that the derivative is ln of x is 1 over x yet. So, but what I'm going to do is I'm going to take my y equals ln of x and use my inverse function. So I get my e to the y equals e to the ln of x. Right? Everybody with me now? Right? Yep, so I take my inverse function of both sides. Why? Because I know how to do the derivative of e to the y, right? So what do I get? I get e to the y is equal to x, right? Do you agree with that? E and ln are inverse functions. They cancel each other out. I get the argument, right? So now I want to derive both sides here, right? So I'm doing d dx of e to the y equals d dx of x. And what do I get on the left side here?
What?
E to the y times?
Well, times y prime.
Y prime. Good. Equals 1. Remember, I'm solving for y prime, right? That's supposed to be prime. I get 1 over e to the y, but look at what e to the y is. Look at on my very same page I'm looking at right now. What is e to the y?
X.
Well, yeah, so I get 1 over x, which we knew, right? So what do we have? Y prime is, if y is e to the x, ln of x, then y prime is 1 over x. But we want our chain rule version, right? If y equals ln of u, what's y prime?
Ln of u times u prime.
So from the ln I get 1 over, right?
Oh, 1 over?
1 over
prime?
u, and then I need to multiply by the derivative of the inside, u prime. So I get u prime over u.
Ding ding. Something I remembered. Or it's coming back to me a little bit.
Nice. Let's do a couple.
It's like a flash of light bulb.
Yeah, nice. So that's it. That's the lecture today. It's that short. So let's just do some problems and see how we do. Okay. I'm not assigning homework from this section. I am not going to be testing on this section, but I just want to show you a way we could use this process in a problem I am giving you on your next test. Right? So I want to do a problem. This is problem 33. Okay. So this is 3.7, number 33. And so I have a function I want to find the derivative of. I've got 2x plus 1 to the 5th times x to the 4th minus 3 all raised to the 6th. And you can see this looks like a problem from our chain rule, right? It's a product rule and a chain rule, right? And so I'm going to start it with the product rule, and then I'm going to switch quickly to an ln problem. I probably should do something first, but I'm a little impatient today. So this is a product rule problem, right? What do I get? I get 2x plus 1 to the 5th, and my derivative there is 5 times 2x plus 1 to the 4th times another 2, right? That 2 is from the derivative of the inside, right? And my second function is x to the 4th minus 3 quantity to the 6th, and my derivative is 6 times x to the 4th minus 3 to the 5th, all to the 5th power times a 4x cubed. It's okay. Yes, you with me? Yep. So
far, so good.
Yep. So, and then I put everything together and start factoring, right? Yes, you with me? We did one of these before, right? So now I know y prime is 24x cubed times 2x plus 1 to the 5th times x to the 4th minus 3 quantity to the 5th. That's this diagonal, right? Plus 10 times 2x plus 1 to the 4th times x to the 4th minus 3 to the 6th. And that is this diagonal, right? And then factor, correct? You remember doing one like this? Yeah. So, but I'm going to stop because I want to introduce the ln trick. So, etc., or excedrin, if you have a headache, which you probably will.
Well, that would be a sufficient answer.
No, we have to factor everything. Right, so there's
You would keep going.
Keep going, but we did this before, so I want to stop because I want to show you the ln trick. Okay? So you certainly could finish that, right? And at the end, you should have something completely factored, right? Do you want me to finish it with factoring?
Yes, please. Yes, please. I just want
Damn it, I shouldn't have asked. Okay, I can see a 2 comes out of the 24 and the 10. I can see 2x minus 5, sorry, 2x plus 1 to the 4th coming out, right? And I can see an x to the 4th minus 3 to the 5th coming out. And what's left over? Looks like I have a 12x cubed times a 2x plus 1 and plus a 5 times an x to the 4th minus 3. So I have to just work inside my square brackets there. I have a 2 times 2x plus 1 to the 4th times an x to the 4th minus 3 to the 5th. I've got a 24x to the 4th plus a 12x cubed plus a 5x to the 4th minus a 15. I still don't know if this part is factorable or not. But because I wouldn't say keep going like this, that's why I'm going fast. 29x to the 4th plus 12x cubed minus 15. Yuck. Typically for me, when I'm trying to see if this really complicated piece at the end is factorable, and I know the only way I'm going to ever do it is synthetic division, but I would look at the graph, right? I would look at this particular graph first and see if it's even possible to be factored. But I'm going to stop there because the one I'm going to give you on your test will clearly be factorable. Off soon. Question?
How does the like looking at the graph tell you whether it's going to be factored?
If I look at this graph and it does something like this, I know it can't be factored. It has no zeros, right? Remember, factoring is going to help us find zeros, right? If I look at this graph and it does this, right? I know it has a factor of 1.
But doesn't that mean there are no like real zeros? So technically.
Exactly, but remember, we're not dealing with complex numbers. That's a 3. So we're doing a 100 level calculus class. The calculus with imaginary numbers is a 300 level class. And Noel will take it. He's a math major. None of the rest of you will take it. It's a beautiful course, though, Noel. You'll love it.
Unless you're a masochist.
Masochist?
Yeah.
Or a mathlete?
You said that's like a Math 3 course?
It's a 300 level, yeah.
Oh, okay.
Yeah, right. So we're doing 100 level right now. 200 level would be advanced calculus. Well, your linear algebra is in 200 level. Your Diffie-Hughes is 200 level. Calc 3 is 200 level. 300 level, is something called real analysis, complex analysis. That's the calculus with complex numbers. 400 level is advanced calculus. We prove everything in calculus. 2 classes of advanced calculus.
That's how you become the math teacher.
Yeah, or theoretical mathematician, where you're just sitting there proving things all day.
That's it. And they get to stretch their heads all day.
Yes. All right.
Or they anger.
Back to the ln trick. I'm going to take the ln of both sides. So I take the ln of y, and I take the ln of the right side, which is 2x plus 1 to the 5th, times x to the 4th minus 3 quantity to the 6th. But I know how to take the derivative of the left-hand side now. But why am I doing this? Because from pre-cal, I learned all these properties of ln's. The ln of a product is the sum of ln's. So this right-hand side simplifies to ln of 2x plus 1 to the 5th plus ln of x to the 4th minus 3 all to the 6th, right? So these are all these properties from pre-cal I learned about log functions. And then I see something else on the right-hand side there, right? First of all, do you agree with me on this, right? We learned that ln of a times b is ln of a plus ln of b, right? We learned that in pre-cal. We didn't know why we were doing it, but we did it. So, but there's something about that exponent, right? My exponent of 5 and my exponent of 6, there's a property for ln's there too. They come down as a coefficient. So now I have 5 times the ln of 2x plus 1 plus 6 times the ln of x to the 4th minus 3. Reminding myself that the ln of u, if y equals the ln of u, y prime is u prime over u. So you can see that when I take these derivatives now, they're going to be very, very simple. So I'm ready to take my derivative. So I'm going to take the derivative of both sides. I'm going to take the derivative of both sides. What happens on the left? Look at my little box here with my property.
5 times 2 over...
Oh yeah, start on the left side though. Y prime over y. Right? So the ln of y has a derivative of y prime over y. And now, the right side. 5 times, what's the derivative of the inside? 2 over the inside, 2x plus 1. Plus 6 times the derivative of the inside.
4x cubed?
Yep, 4x cubed over the inside, x to the 4th minus 3. oh my God, look how much easier it is, right? So much easier to do this. So I have y prime equals y times 10 over 2x plus 1 plus 24x cubed over 4x minus 3. Now, what's going to happen? I'm going to end at the same place, but it just makes taking the derivative a little bit simpler, right? It makes taking this derivative a little bit more simple. Still, it turns out I have to do some factoring, but it's not as bad, right? So what did I have originally? 2x plus 1 to the 5th times 4x to the 4th minus 3 to the 6th. That's my y value, right? Right, so I sub y back in, the original function back in.
And they became to the power of 5 and 6 because you...
That's the original problem. That's
okay.
the original problem, right?
Realization,
Yep,
yeah.
Yep. So I keep going. I will end up with the same exact answer. Look at my original answer here, right? Do you see? Look at this power goes to the 4th and this power goes to the 5th. Can you see why? Right, you see right now I have a 5th power and a 6th power, but it's going to go to the 4th and the 5th. Do you see why? Because there's some fraction in there, right? There's some denominator it's going to cancel with it. So the way I'm going to finish is a little different. I'm going to keep my 2x plus 1 to the 4th outside, and my x to the 4th minus 3 to the outside, but to the 5th power, and I'm going to pull one of those factors into each numerator. So I get 10 times a 2x plus 1 times an x to the 4th minus 3 all over 2x plus 1. And then I get 24x cubed times 2x plus 1 times x to the 4th minus 3 all over again and x to the 4th minus 3. So that I can see one of those cancel here.
That's a really cool way of solving it.
Yeah, it's a lot easier. And now you can see the inside square bracket is exactly what I had before, right? That inside square bracket is exactly what I had before. So I don't have to keep going because we already know, right, what's going to happen in there. I'm going to cheat because I don't feel like doing it again. 29x to the 4th, 12x cubed. What was it, minus 15?
Yes.
Thank you. Done. So, if you look at the old test, chapter 3 test, midterms, and it says do the ln trick, you don't have to, right? We're not going to have you do that on the test this time. Just trying to simplify it a little bit. I'm trying to make my test a little easier. I feel like I got a little carried away in a couple of semesters.
Excuse me.
Yes, Mark. Yes. Yes.
Professor?
Yes.
For chapter 3, are we going to go over 3.8 and 3.9?
No, it's too specific to bio or what is it? 3.8 is
linear approximations and difference.
Yeah, it's natural and social science is 3.8. So I guess if you're a bio major, you'd want to look at that, but you don't have to. And then 3.9 is linear approximations and differentials. I'll talk about that later. I'll talk about differentials when we do chapter 5.
So we just have to do 3.1 to 3.6 for the test.
4, 5, and 6 for the test. Yes.